Hey, Dawn here. Well, I'm making a new. Oh, I know what it is. I turned my music on. Oh, now it quit. Oh, okay. Well, this is driving me. Okay, there we go. Now I'm okay. I did something new. I'll just show you what I did and what messed me up, and then I'll come back to what I'm gonna really do. Okay, so I got this machine in remote desktop, this Windows machine in the web browser because I didn't want to run it in. I've got so much going on the machine I'm recording on. It's just I know it'd be too much for it because YouTube just uses up a lot of resources. So anyway, I wanted to be able to hear the music so that I could cut away from the music to me at a good time in the music because I hate it the way it's been going in my previous videos where I can't hear it. I can't make it a way to where I can hear it on this machine that I'm recording on. So I thought, okay, I'll just listen to my live stream. So I went over there and I had to wait till it to start, and then I had to unmute the audio, and then I went over here, did my switch, and the audio kept playing, and I was just bumfuzzled. I just like, what the heck's going on? I don't understand. And that's because it was still playing on the live stream, and it was behind. And I had to use the headset to hear it because, well, that machine doesn't even have an audio cable plugged into it. So I don't have enough audio cables to have them all plugged in, and it's hard to get to back there. So I just thought, well, I'll just plug in my headset. It doesn't matter. So anyway, hey, this is Don, and I got a new toy. You see that box? You know what that is? That is an Arduino Uno. Let me put it back over here. And here it is over here. It's my first one ever. I've read about them for years. And I'm trying to see where I could put it and it still be seen. Can kind of be seen there. Well, let me hold it up. I got to be careful because I have my speaker wired to it for my tests or my first run or whatever. I can't really get. I didn't zoom in because I didn't want to be too. I don't know. I wasn't quite sure how far to zoom in. I didn't. I spent so long reading about it today. I didn't want to spend forever setting up the video. Now I can't figure out how to set it down. The mic thing in the way. So yeah, this is probably where I'll set it while I'm doing it, or either there or here. Oh, I can set it here because I probably still need to get to my my keyboard. Well, that doesn't have it up in the picture though, does it? Yeah, I can still reach my keyboard like that. I don't think I'm going to do a lot of typing anyway. So yeah, let's just have it over here, because that's going to be one of the main things, is having it to where the I was looking at it where you got to plug it in, see if this will, and also wanted this speaker to be able to reach to the microphone so that I can let you hear what's going on. I've got it. Normally I would, like hold the camera up close and use the magnifying glass. I have to use the magnifying glass to see everything, but it was really hard to know that. Well, at first I was counting these pins. This is what they call a header where you plug stuff in, and I was counting them to try to get the right one. It said, to plug in the positive on the 10 and the ground on the ground, and it's marked on the inside of the board, but they don't line up. And then finally, after I had it hooked up, and I did get it right, because after I got it hooked up, it's marked on the outside of the header as well, and it's right in the right place. So, but I just used I had a nice, good, stiff, solid core wire. And actually, luckily, my speaker, this is a speaker out of a computer, I think. Yeah, that's what it is. Yeah, because that's a computer connector. That's the internal box speaker of a desktop computer. One that I guess died, and I saved the parts out of. And then, so all I had to do is plug my wire into the connector. And I just used a paper clip for my ground connector. and I made sure it was up there where it can't be, it'll turn, but it won't short on anything. And the positive wires, I cut them short enough where it couldn't touch them, So, and it has a plastic kind of a base for it to set in, and it wasn't, screwed in. And it has enough screws you can screw this down, and then there's extra screw holes that you could leave it that way all the time, and then screw and unscrew the base from whatever project you're working on. This is a if you've never heard of them, this is an Uno. This is Arduino Uno. A lot of people say Arduino a lot of different ways, but Arduino is the best way I can say it. Uno Revision 3, Rev 3. That's what this one is. And it was it was given to me by element14.com. I've been kind of a member of that site for several years, so 3 or 4 or 5 years, 3 or 4 years, I don't know. When I first discovered it, they still do this. They do what they call road tests, and this is not a road test though. I just got this for Christmas in January. I got it like a week or so ago, and they just had a bunch of stuff to give away, and they just said everybody write a little story about what got you into electronics and why you love electronics and stuff. And I wrote mine, and actually I had done a couple of road tests, and so I had already told that story in one of them, so I put most of that in there, and then I added to it, and so they liked it, and they sent out a bunch of them. I could tell because it was like there's a forum where people make comments, and I get emails from the ones that I'm interested in, and so of course I was interested in that one. So a whole bunch of people got them. They've been getting them ever since I got mine. I guess one of the earlier ones, and then because I remember 1 or 2 people said they got one, and then I got mine, and then now a bunch of people are saying, "Oh, I got one," and we didn't know. Nobody knew who was going to get them. With the road test, they tell you sign up, and then they pick the people they think will write the best articles for, and that understand that particular item that they're giving away, and they give it to you in return for a review. And so I got to do 2 of them. 3 of them. I got to do 3 different things, and actually they're you can see some of them right there. 2 Texas Instruments development boards. Well, actually one of them has 2. They have a wireless. It's called Zigbee networking. Is what they call. Well, they don't call it that in there. It's called Aaron something or other wireless, but it's a Zigbee. Zigbee protocol is what it's generally called, and then the other one is the TI 430 MP 430. I think it was. It's the older model now. They have newer models, and then that's all that's up there. Anyway, you can see those, and the other thing was it was a wireless keyboard. I've got it laying around here somewhere. I guess I put it away. It's a mini keyboard. They made a little kit and an SD card and stuff to go for your Raspberry Pi. If you've heard of the Raspberry Pi single board computer, I had to buy the Pi. I mean, I didn't have one, and so I thought, well, I'll buy one if I win, if I win that or get picked for that review, and I did. So I bought me one, and I did a project with it and wrote about it, and so anyway. They just gave these out, and also I got. I might as well show that too. I haven't learned anything about this yet. This is called a code bug, and it's supposed to teach you programming and stuff, and it's just a smaller version. It's got a bunch of LEDs on it and stuff, and it's kind of I don't know I forgot what the chip is on it. It's not the same as the Arduino, but. Actually, I didn't realize that it was wrapped, and I said, "Oh, how neat! It's wrapped, Christmas present, And anyway, somebody commented back. I made a video and put it up, and somebody commented back and said, "Well, you're supposed to give that to somebody." I thought, "Oh, well, I guess I can test it out and then give it to somebody." So my nose is itching like crazy. So I'd already opened it. So, and besides, I want to learn about it because I'm a kid when it comes to this stuff because I've always loved electronics, but I didn't get to. Be an electronics engineer. Most of those people that are on that side are electronics engineers and stuff. And I didn't get to do all that, be all that. One, you really do need to be good at math, and I've never been good at math. But I used a lot of electronics. I ran sound for bands for quite a few years, and I've really been into all things electronics ever since I was a little kid. I started out with a little reel-to-reel cassette recorder, AM radio, and then a reel-to-reel cassette recorder, and then a reel-to-reel tape recorder, and then a cassette recorder, and I wired and rewired speakers and did this and did that. Learned to solder on my AM radio. It kept working, and I fixed it because I figured out that the solders had just cracked and came loose from the little transistors and stuff. And so I heated them back up with a soldering gun. I had played with one for a long time already. I kind of knew how to melt. I knew how to melt solder. Anyway, I figured out how to fix it. Just nobody telling me. Just figured it out. And anyway, I always loved that stuff. So this is what they call a development board, and you can. This one's pretty versatile. They are a little computer, but they're more like. Can you see? You can't really see it, but that's my my Radio Shack TS80. I can't think of anything right now. I guess I'm too tired. I've been reading all day. TR80 Radio Shack portable computer from 1983. Somebody gave me that, and this has about the same processing power as this. About the same, close to the same memory. This has an onboard memory chip of I think I already forgot what it was. Let me go ahead and go to my desktop, and I'll start going through some of this, because that's part of what I was going to do. It has, and go through each page. I had them kind of up here in the order of the way I was going to do it, but I'm going to do my first project on here right during my video. I've never. Let's make sure I'm on the desktop. Make sure I'm showing what I'm supposed to be showing. But the microcontroller is an Amiga 328P. Operating voltage is 5 volts. And it depends. There's 3 ways, but 2 good ways that they really recommend you power it, and that's either from a USB printer cable. Really, is what it would be called. Everybody calls them. It's what they're for. They fit. It's the only thing I've ever seen them used on until now. But I had some of those, so that was good. Input voltage on I always called it a barrel jack. I was reading an article about powering the things, and you called it a Japanese jack or Japan jack. I never even heard it called that in my life before. But I call it a barrel jack because it's shaped like a barrel, and that's what most people do right out, calling them. But anyway, 7 to 12 volts. And input voltage limit 6 to 20. And they say don't power it over 12 volts, or it's gonna end up burning up. I've been reading about it all day. A bunch of it's got a PWM, pulse width modulator. It's got digital inputs and outputs, analog input and input pins, DC current, 20 milliamp, DC current on the 3.3 volt. There's some 3.3 volt pins on here too, 50 milliamps. Flash memory, 32 kilobyte on the Amiga 328P. And I can't remember if the TRS-80, the Radio Shack TRS-80 has more than that or not, but it's not a whole lot more if it does. And it has RAM. I'm thinking of the RAM. This flash memory is writable memory. It's not the RAM of it. It has SRAM, 2 kilobytes. 2 kilobytes. I think the Radio Shack may have something like 32 kilobytes of RAM in it, and something like that. Maybe 64, but and not megabytes, kilobytes, because the machines I started out with, the 486s and stuff, had like 4 megabytes, and 64 megabytes wasn't coming along until Pentium 1 and Windows 95, So, and then EEPROM 1 kilobyte. I've read about that, and now I've forgotten actually what you do with it. I don't know everything about this stuff. I'm learning about it. Clock speed 16 megahertz. I understand that, and that is. Let's see, what was the 486? What was that? It's more than that. I think 46 might have been like 32 megahertz or see. let's see. I've already forgotten now. It was common to have 32 megahertz, 64 megahertz, and then it just went up and up and up. Now we're in the gigahertz range. LED, LED built in, BUILT-in, yeah, built in 13. Oh, I thought it only had like one or two. And then the size, and it's in millimeters, so that doesn't mean anything to me. If you don't give me inches, I don't know what you're talking about. Or weight, 25 grams. So I guess I could length 6.60. Well, you can read it. You can see it. I'm not going to try to read it out. Okay, so let me get a drink of water here. So, and there's a lot more specs on the page, but it's at Arduino.cc. They're actually made in Italy. They're invented by an Italian guy, and so they're actually made and produced in Italy. One of the first things I found, and I've read on them about them on and off over the years, so once I got this, I started going back looking through my links. And actually, most of my reading I've been able to do from my original research links. And then maybe like I spent all day on their page reading their official documentation, But here's a good article, 10 Ways to Destroy Your Arduino, and I'm glad I read it. And it's actually written by some company here that makes what they call and it tells you, how you can burn it up and what not to do. And then they say, but our, what's it called? Ruggedino. They have one, I don't know what it costs or anything, but theirs has all this protection in it so that everything that they're saying, the common ways you could burn up an Arduino, 10 of them, their Ruggedino won't burn up that, you can't blow it out so easily. I'm sure you can blow it out one way or the other if you tried, but I guess that's a picture of theirs. Yeah, it looks a lot different, doesn't it? But after I was reading along, some of the things that they said it didn't have, like a protection circuit on the input, I read somewhere that it does. This model does. This is a newer model, I think, than what they were talking about. I'm not sure when this was, but some of my links, I saved a few years ago. And I run Fedora 20. I'm running on Fedora 23 right here, this machine. And it's, I just kept making sure I'm on the remote desktop. Let me go make sure my stream looks good and everything. Yeah, everything looks healthy. Okay. So I think I should start closing these as I go. I've had this stuff open for a long time, and my Firefox is using up more memory than it needs to. But anyway, it tells you how to. They always tell you that. They don't tell you go look in the repos. When you're in your package manager, like Yum Extender or Apper to install stuff. They always tell you the commands. And so I went to actually. I already had it installed because this system I installed a bunch of groups of program types, and I believe I got it by just installing the electronics group. There it is right there, Arduino IDE. Of course, I think your Arduino is not exactly the way it's spelled, like Arduino, R-D-U-I-N-O, Arduino. I can't. It's dang near impossible to say, for me to say. Most people, I think, people that, I guess if you spoke Italian, maybe you could say it right. I almost want to say that I read about how it was named and all that stuff, and I don't know. It's supposed to mean something to them, It's hard to say it was like take on the guy's name, but I don't think so. I think it means something. Sort of like Firefox is a little bear, and all that stuff. But little orange bear. See that little orange thing? That's supposed to be the orange bear hugging the world, I've seen the actual what they had in a Firefox mascot one time a few years ago on a live webcam. A couple little bears that got born in a zoo somewhere, little Firefox bear. They call them Firefox, but they're actually little bears. I forget where they live. They eat leaves instead of people, though, at least. So I like them grizzly bears we got here in America, and the polar bears up in Alaska. They eat people and deer and seals and stuff like that. But they don't eat people a whole lot, just sometimes when they're really hungry. But Uh, anyway, this is Fedora 22 and later I got Fedora 23, so I went and looked, and I didn't have to install it. I already had it installed, but I did add a couple of apps. Saw a few more that looked really interesting that I added. Actually meant to have my I can check on my. These are some of the things I downloaded today, PDFs about it, and the Arduino program, which I already have, but I went ahead and downloaded it. I actually clicked on it. Just thought I was going to go see what it was. Go to the page and it downloaded it. So, oh well, I can use it. I might need it at some point. And on my screenshots that I took earlier today, I think there might be a couple I wanted to show in here. That's I tried to run a little. I guess you guessed with the speaker. I'm going to run some audio code. I'll start coughing now as soon as I start talking. And I tried one that was Python. It took you put Python together with Arduino. Doesn't run Python. It runs basically C code. Dave the EV blogger, watched one of his videos today, and I actually realized I'd already seen it before, but it'd been a long time. But he knows his stuff, and he said it's run C code. So I didn't realize that because they call them sketches, and they didn't really talk about what kind of code it runs on it. But so Python I actually took a Python class from when Google's Audacity online university thing was free when it first started out, and I took a Python class, and I didn't actually finish. I tried to take too many classes at once, and I quit. I couldn't handle it. But and I was getting the test right, but I wasn't really understanding it. But I did learn a little bit. I mean, kind of. Anyway, this is a screenshot of some Python code, and I was in here in this program called Genie, and I was trying to see if I could run it, and kept getting errors, so I thought, well, I don't know how to fix it, so I didn't keep messing with it. But I installed an add-on for Eclipse, an IDE that I've used before for my Texas Instruments boards, and I believe I was able to write the image to the code to the Texas Instruments board with Eclipse, I think, if I remember right. And I don't remember which one it was, Eclipse or one of these IDEs. I have a bunch on this machine. There's plenty more than these. I had my Fedora 14 machine. I have about 10 or 15 of them on there. Let's see, is Eclipse on here? I mean, I guess I have Eclipse on here. I don't see it. I may have installed an add-on for an app I don't even have. Could be somewhere else in there, but I guess I better look. I don't think I have Eclipse. So I installed something that I can't use without. I can go back and install Eclipse later, but Eclipse CDT Arduino, so you could work with Arduino in the Eclipse application. I have it on my Fedora 14. That's how come I got confused. And there's another one. There was two that I installed. I guess I didn't take a screenshot of that, but Mosquito and Eclipse. CTD Arduino and Mosquito. I forgot what Mosquito did, but here it is, Mosquito. Mosquito is an open source message broker that implements the MQ telemetry transport protocol version 3.1 and 3.11. I can barely see that, it's so small. MQ telemetry, let's see, I'll just kind of skip around. Like, what method of carrying messages using publish subscribe model. This makes it suitable for machine-to-machine messaging, such as with low power sensors or mobile devices such as phone, embedded computers, or microcontrollers like the Arduino. So I thought, I've been always wanting to fiddle around with some old mobile phones that I've got laying around, try to do projects with them, and you can, like I saw one where they used the screen off of an old mobile phone for a view screen, and I believe it was a touch screen, but anyway, for an Arduino. So I thought, oh wow, that'd be cool. And Let's see. Then there were some others that there wasn't that many. I just put in Arduino, and there was just a few. A couple I didn't want. Actually, this Fritzing is a program, an IDE that I happened to run into before I started this today. I was reading on hackaday.com. This article about reviews on IDE applications. And they said Fritzing was sucked. It just wasn't any good. And so it's in here, but I didn't install it because they said it wasn't very good, and they said why. So I thought, well, it's just going to confuse me being a beginner, Eclipse, Arduino. So I need to go back and install Eclipse now. I'm not going to use that today. I'm going to use the one that comes with it. But I think that's something else I was doing. Oh, I don't know what that was. Yeah, that was before. That was my first one. And then there was another one to do with. If you're when you install the that was actually important. And I think I'm going to be all right, but if I need to, I could go back and install this. But this actually says when you connect. Have to make it larger again. Whoops. Only when you connect a rip-wrap like a 3D printer to the Linux machine by a USB cable, you need to be in dial-out or similar group to be able to control it via Octoprint, Print Run, Cura, or any other controlled software. Not anymore. Install this. Not anymore. Install this rule to grant all users read and write access to collected devices based on the VID and PID. Process ID, what's the VID? I don't know what VID is. PID is process ID. Disclaimer, such device might not be a 3D printer. It may be an Arduino. It might be a modem. It might be even a blender. But normally you would add your user dial-out to get access to all of those and more anyway. So I guess be careful when some of the users should not get access to your blenders. So they're talking about a food processing blender. So not the application. It threw me off for a second. I was like, what? So anyway. I went ahead, and when I saw that I had already had the application. Where is it? Did I forget to open it back up? Looks like I forgot to open it back up. It's okay, I'll open it up here when I get ready to use it. I guess I'll open it up now. I guess I'll just open it up in this window. There it is, the Arduino IDE. I had it open before I rebooted, and I never did open it back up. So hopefully everything will be fine with it. There it is. Okay, well, first time it opened up, it said you need so-and-so permissions. And I knew what they were talking about because I'd read it in that app there. It said, do you want to grant these permissions now? And then I said, yeah. And I said, yes. And then made me put in my root password, and that's done. So now it's opening up fine. So I don't think I'll have those problems. Because, see, that's the way the Arduino is powered, and the way it communicate to it to write the code to it is with the USB cable, through the USB cable. So, and these are some PDFs that I downloaded. This is the features and stuff of it. And this is a diagram of it. And that's what I have there, Arduino Uno revision 3. And so, anyway, if you wanted to install it, then you could just you could do the commands, install, DNF install Arduino. Well, they say do sudo. I always do su, put in my root password, and then just write DNF install Arduino. Or I usually just still write yum install Arduino, and it just goes ahead and uses DNF and tells you about it. But this page here I read for hours, interfacing with hardware. It has all kinds of links and information about it, and I went through the whole thing and clicked on everyone that interested me and that's how I ended up finding these sketches, they call them. Now here's where I need to start right now. I haven't plugged in the cable yet. I haven't turned it on yet or anything. I thought I'd just do it during my video. And so I'm going to do that. And this is a part of it. Let's see, I've forgotten where I was. It's been so long now. Oh, this is installing, I think, which I had already done. I was just skipping through it. Yeah, install the IDE. That's what that page is, how to install it. And so it says you might happen when you upload a sketch after you have sketched your board and serial port, selected your board and serial port, you get an error opening serial port because it uses serial through USB because this machine probably doesn't have a serial port. I still got plenty of machines that do have real serial ports on them, but anyway, this one does. I don't think it does, but if you get the error, you need to set serial port permission. So I thought, well, I may have to have that command, so I saved that back, and in case it happens. And then here's one of the sketches I wanted to try out. Well, I'll just try out I'll go to those in a minute. There's two of them, and they'll play sound through the speaker. And that's why I have the speaker hooked up. And I read in where actually on this one you hook the speaker up to the speaker between pin 10 and ground. So I put the positive on pin 10 and the ground on the ground. And then the other one, it says put the pin on 11 and pin 11 using pulse width for audio. So that's going to do the PWM is going to be making the audio. I believe. Well, maybe not. I can't remember if I was thinking the pulse width stuff was PWM was on the other side. It tells you on here where the PWM. No, it's in the PWM area. Actually 10S too, I guess. If I understand it right, all the pins 7 through 13 are PWM ports, pulse width modulation ports. So, or I call them ports, pins. And this one here, I'll just mention it right now. This was a pretty good article about, what to do and not to do. Well, first off, I'll just show this picture. Nowhere on this thing can I find that it's marked. Every kind of consumer electronics or everything I've ever seen has there's the barrel connector over here, and it's usually they're marked with the polarity, the plus and minus, which one's which on your barrel connector or whatever connector you've got. I mean, usually they don't do it on the USBs because you can't get them wrong, but the voltage and the pin and the polarity of the pin out, and it wasn't marked. So I thought, man, I'm not going to be using that. I'm going to be using the USB cable, but I want to know that. So I started searching, and they can be either way. They can be positive in the center and the center pin, and the barrel can be negative, which is what this is, or they can be just the opposite. You really have to pay attention, or some things you'll just blow them out. And it does have a protection circuit in it. It says, that it won't burn it up. Most of the time, if you put a high voltage in there, it might. It's what I think this article said. Actually, this is on the forum, the Arduino forum, but this is Arduino forum, so I figured this would have been taken down if it was wrong. So this was a good image. It shows what a lot of the stuff is. It's all labeled, And so anyway, there's the barrel connector and there's the USB connector. And just to make sure I'm in the right places here and everything's going good. Okay. When I say in the right places, I mean make sure that I'm doing a desktop video and not showing myself. Okay, so this article here is going through the same thing, but in a lot more detail. That was just a question on the forum being answered with a good diagram. But the guy, he's mentioned something here that I hadn't even run across that I remember ever in my life. But I can tell he's in Europe because he's talking about 240 volts, 220, 240 volts. So maybe it's more common over there. But see those two brick power supplies, those two wall warts? One of those puts out AC power. And I don't remember ever seeing that. He said they're common with modems. and this one on the right off. And I was thinking, oh yeah, probably the one on the left because that's a bigger cable coming out of it. No, it's the one on the right, and it's marked. I couldn't read it until you can barely read it, but it says AC 12 volts, 500 milliamps, and this one says output says plus 5 volts, 2 amps, and he says, well, it's obvious that that's DC. And I was thinking, well, it doesn't say DC. Most of them say DC, and when you get them here in America, they usually say the DC voltage, DCV or something, DC or DCV. And then it shows the pinout. And he says, well, then one other way you can tell is because the DC ones will always show you the pinout or the polarity. And so I was like, oh, okay, good to know. So pay attention to your power supplies. And then I already had this question in my mind, unregulated. I have quite a few of these that I bought years ago really cheap. And back when they used to mostly what you got. And unregulated, well, when there's no load, they'll usually show a higher. I have one, I think it has a picture of one. Yeah, I've got one like this. Might even be the same brand, I'm not sure. Very similar, and you can switch to different voltages. And I thought they were bad because, and until I learned this last year or a few months ago or whenever, I was reading another article. They're unregulated, so when there's no load on them, like you put it on 9 volts, and it'd be putting out about 12 volts. But when you put the load on it, it'll drag it back down. And but they're still not constant. They don't keep a good level voltage. He said, don't use them. And then this one is a regulated one. And he goes into everything about it. And he has diagrams and everything. And he talks and he writes in extremely technical terms, and he uses words that, he doesn't write. He writes like he may be English or something because he writes real proper. He doesn't make mistakes in his language like some people do. A lot of electronics people are really intelligent, but some of them are not English, not American, they're not Australian, or whatever, and they don't know English very well, and they'll write things wrong, and it's kind of hard to follow them. But this guy's hard to follow because he uses such. They're not such technical words. It's like he's writing a fancy book back in 1890. He's using some of those old words. So, but if you can get past that, he really helps details. Now, he may be writing about older models of Arduinos because some of these things that he's saying are, one of the things he's saying, I'll show that in a minute. See, now that's a European 220 volt wall wart. So this one is regulated, and he actually said, let's see, once regulated, and then switching power supplies. Okay, this one is regulated linear power supplies, and then this one is a switching power supply. And it actually, I saw that in the diagram, has a PWM as part of what makes it work. And I'm like, oh, okay, pulse width modulation. So anyway, the switching power supply, and I'm not going to try to, this took a long time to read through this. It's got so much information, I started skipping the battery part. But anyway, he didn't care too much for using these either, the switch mode, because he said they're not very, basically what most people call clean voltage. It varies not in voltage so much, but in, I may have to read what he said because I'm not an expert on this stuff. I understand it when I read it, but then trying to tell it back is a little harder. They're highly efficient, and they don't waste. Well, what they waste, they make heat. What they do in order to, these other ones, they make a lot of heat as a byproduct of regulating the voltage. The voltage regulators end up making, and they have to. He was saying they have to be really big. They have to have heat. They usually they have something to dissipate the heat inside. You don't usually see like fins like you'd see inside a computer, but you'll see something, a heat sink of some sort. So noise filtering and dirty electricity, noise. They don't have to pay little attention to noise filtering. So he didn't think you should use those. And so I don't know. I need to get on them. Before I try to hook up a regular power supply to it, if I decide to, then I'll make sure I get the right one. I'll go back on the Arduino site and see what they recommend. And then batteries. He went into real good. I mean, it looks like great detail on batteries, and he explains parallel wiring batteries in parallel. The voltage stays the same, like that. And I'll just skip to the next image. You can do that on here. And in series, you go positive, negative, and the voltage goes up as you do that. And every time you add another 1.2, that says 1-2, but 1,2, but it's 1.2 volts. I don't know why some people in other countries use a comma instead of a dot, because it's 1.2. It's not 1,2. So I don't know how that got to be acceptable, but it just always throws me off because that looks like they're trying to say 1,200 and abbreviated it, So, because some people do that instead of writing out 1,200, which is not right, but they do it. Okay, there's a LiPo battery charger. He goes into LiPo batteries. He goes into just everything, it's pretty cool. And then he has a real good diagram and even a picture of a barrel connector here with an Arduino. This is an Uno, but it's not a revision 3. I noticed that. So I think this is an older one. So some of the things he's saying in here applied to this version, and I think there's some upgrades in the one I have, like protection circuits and stuff, because there is a protection circuit. And one thing he explains, and I've read this on the Arduino site, you can plug in, if you plug in the USB cable, and for whatever reason you want, well, let's say maybe you had some peripherals you wanted to plug in here, some extra stuff you're going to plug into these headers here, extra add-on boards, then you might need more power than the computer 5-volt, 240 milliamps or whatever that it puts out, I think. You could plug in this, and you don't put 5-volt power supply, and I didn't realize that. You put 7, anywhere between 7 and 12 is good. It can handle from 5 to 20 without blowing up, but you don't want to run it on more than 12, and you don't want to run it on less than 7 from this jack here. But what happens is if you plug this in and then plug this in, then this one will stop feeding power, but it'll just do the data. And this one will power this and everything plugged into the header pins. And then he goes into how to power it from here, but they warn you over and over in the Arduino website, don't do that. It's dangerous. Because you're bypassing the protection circuits and you could burn up your Arduino. So, so this is a real good article, but either he's just braver than the Arduino people want you to be, or he's behind on the, this is an older article. I didn't even look at the date. It probably is an older article. So, anyway, it is good though. But if I hadn't have seen all the stuff on the Arduino site first, then it would have probably misinformed me a little bit as for my particular model. I made sure when I was reading on the Arduino site that I saw that it was Arduino Uno at least. Actually, I think that other one was Arduino Uno, wasn't it? Just an older one. This one doesn't say revision 3 on it either. Actually, that revision's not on the front; it's on the back. That's right. You can't tell from the front. It's on the back. Yeah, it's on the back, so you can't tell that way anyway. I can't flip it over with all my stuff on there. I'll knock it loose. But let's see. Yeah, I don't need that picture anymore either. I don't guess I really need that one with the diagrams. This one, this page here, Uno and Genuino. I don't know I never heard of the Genuino. It must be brand new. Genuino. I used to say just be Arduino. Because when I first saw that Arduino, when I finally settled on just calling it Arduino, I used to say Arduino, I don't know, just to be silly. Of course, I was talking to myself, not to people. Did I say that out loud? So, yeah, I guess I did. So here we go. Let's see. Now I'm ready to kind of get started on it. Let's see. Make sure my health of my stream is still good, and my file is growing over here. That means I'm getting a good file and good audio. Make sure I didn't click on the wrong thing. And actually, I'm going to want to click on the wrong thing I'm going to want to click to my camera when I get ready to do the actual stuff here. So I am on the desktop. Okay. I would not bother you with that so much if I was using a laptop, but I don't have one powerful enough because I could have the control on the laptop screen and what I'm doing, my work on my screencast on the big screen, on the on the LCD monitor, but can't do that with this machine. So I probably could do, well, no, it doesn't have enough video memory to do dual monitors. It has 2 monitor outputs, but VGA and DVI, but it's only 256 megabytes of memory, so there's no way. Now, I may have to. Oh, how did I do that? There we go. Sorry, I'm distracted here. Turn things over. Little by little, I'm getting more and more raw in the throat, so I'm getting a cough drop. And I hate getting them while I'm doing this because that makes me smack on the microphone. So I'm just going to get it out. Well, no, I better just start it. Other than, when I was using DTK record my desktop, I could pause. I dropped it. I can't pause like in GTK record my desktop. So, and this is live, so help! I dropped my cough drop. You know what? It's gone. It hit the floor, so I don't guess I want it anymore. Anyway, that's aggravating. All right, let's try getting another one. You can, here, I'll page down where you can read some more of that. Sorry. Okay, give you something to do while you're already gone anyway and already clicked off and went to watch something else. But, hey, this is live, you know, you can't do nothing about it. There's no editing in live. That's why I like live. Because I don't have to edit it. Okay, oh yeah, of course if anybody was to try to chat at me over here, I wouldn't know it. So, but if I was to ever do these and people started actually watching it while it was live, then I might have to get me somebody to help or something. Okay. Let's see, now we're going to connect our USB. It's not just to power it up, but to and draw power, but it's also to let's see. Okay, yeah, the green LED is going to light up when you plug it in. It's how you program it. It says it in there somewhere. I can't even read right now for some reason. Getting this cough drop and dropping one and everything just threw me way off. Okay, so I'm using Linux. Okay, oh, you'll have to install drivers on Windows. Control panel. Okay, yeah, now I can skip on back down where I was. Open an LED example. Okay, so first thing I'm going to do, I'll go over here. I'm going to get on the camera, and we'll magically plug this thing in, as if by magic. We will show you this. I guess I'll turn it around. I guess it's better to just leave it where it is. I think maybe I want to put this. Well, it doesn't want to go that way. My wires are so stiff. So, yeah, I think that'll work. This USB cable is so big and heavy, it's going to drag it off here. Okay, there we go. Green LED. Actually, you could saw it better down on the table, I think. Oh, and there's a little red one blink, a little yellow one blinking too. So let me see if I can put some of this cable up on something besides. Whoops! I think that made it worse. At least it's long enough. Yeah, this is one of those kind of things where the cable is 10 times heavier than the computer. But there it is. It's running. Didn't make any noise. I didn't really think it would. Well, I didn't know if it might make a little beep or something out of that speaker since I happen to have it plugged in there. But I'm trying to see if there's a better place to. Yeah, I think I like it better there. Maybe. Actually, I don't, because that puts that wire right where if I reach for the keyboard, I'm going to get my thumb in it. Okay. So we're going to go back to our desktop. Open the LED blink example. I'm going to do that first because I know that one should work. 01 basic blink. Okay. You'll need to select the entry in the tools board menu that corresponds to your Arduino or Arduino board. Okay, yeah. Let's go open that up. Where is it? I think I'll close that diagram. It's really not going to help me. This whole PDF about it, I think I will leave up because that's about the Atmel controller. That's the data sheet for it. Who knows, it might be useful. Okay, so I'm going to go back to my instructions. Examples. 1 basic. Oh, okay. Digital analog communication control sensors. I really didn't pay attention to that. I was so busy reading on the website. And this is just some basic code that opened up. It was just there. It says put your step code here to run once. Put your main code here to run repeatedly. And I actually watched a couple little videos too. A guy, Ben Heck, on Element 14. He makes projects and he uses Arduinos a lot. He had a good quick everything. He said everything you need to know to do an Arduino. I watched that first, and that did help quite a bit because he went so fast I couldn't follow some of it. But examples, basics. I'll have to go back and look again. That's my problem, is I forget. Blink. Okay, we want to go examples, basics, blink. Okay. Oh, we opened up a new one. Well, I'll make it big like that so that I don't forget and get mixed up. Okay, it turns on an LED for 1 second, then off for 1 second repeatedly. Most Arduinos have an onboard LED you can control. On the Uno and Leonardo, it is attached to a digital pin 13. If you're unsure what pin the onboard LED is connected to, put your on your Arduino model, check the document here. Okay. This example code is in public domain. Okay. Modified May 28, 14 by Scott Fitzgerald. The setup function runs once when you press the reset power or power the board. Okay. Or power the board. Void setup. Initialize the digitized pin 13 as output. Loop function runs over and over again forever. Okay. Digital write 13 is really simple language. It's simpler than Python even. This is what I always thought C code was really complicated. I thought C code was where you had to where it was what do you call it? Where everything's in symbols and and you have to learn all that stuff. You have to have a program that can read those, interpret and write those symbols and all that. Like I used to look at my first kind of programming applications I ever looked in were for Windows applications, and that's what I saw. Only thing I could read were the notes. That's why I never tried to learn programming after seeing that. There was a few things I ran into that you could actually see real values like this and change them, and I fiddled around with them a little bit, but it was just too hard to make it. You just get errors, and I did some kind of change I wanted to do and then successfully changed something once or twice, but just for fun, Delay 1 0 0 1 2. I can't tell if that's 3 or 4 zeros. Imagine that's in milliseconds. I understand that kind of stuff from running audio and effects and delay and reverb and compression and all that stuff, which I'm actually using on my V-amp here to get a decent sound off my mic. But this thing will talk to MIDI, and you can do all kinds of MIDI projects with it. I might actually do something like that. I never have been into MIDI music, but MIDI as a controller interface, I've always thought would really be a lot of interesting things you could do with it. And with an Arduino, you could do, something besides just playing sounds, which that's cool. I mean, you can do that too, but you can make a little synthesizer even if you want. But I saw a project in a video today where a guy used piezo sensors and stuff, and he had made a little drum kit, and he had 3 or 4 buttons, and then he had sensors that if you hit them harder, it would be sensitive to the hit and the touch, and it was pretty neat. And he used MIDI, and he changed the sound, because that's what you can do that with MIDI. The computer plays the sound, and he turned it into scary sounds for Halloween. He showed it as a drum kit at first, and then he changed the sounds, and it was scary sounds for Halloween. It was pretty neat. So, okay, now let's go on to the next. I got sidetracked. Okay, and it's just sitting there running now, and the little yellow light quit blinking. And make sure everything I did is still hooked up and I didn't knock anything loose. Yeah, this is not going to do the speaker. It's just going to do the light. But I wanted to hook that speaker up ahead of time because I knew it was going to be hard for me to do because I don't see good. But okay, so then you go. Okay. Oh yeah, you'll need to need to select the entry in the toolboard menu corresponds to your Arduino. Okay, so I got to go to Tools, Board Arduino Uno, and you want to pick the right one. Okay, so hopefully that'll be easy enough. Tools, Board. Let's see. Go over here. Yeah, okay. Make sure I'm good. Tools. Auto format, archive, sketch, fix encoding, reload, serial monitor, board, port. I thought you had to select a port. I saw that in some of the videos. I'll just do what they tell me, one thing at a time. I see the one that says Arduino Uno though, so that's the one I'll be wanting. They said if you have trouble figuring out which one, unplug your USB cable and plug it back in, and the one that goes away and comes back is yours. So that's pretty good. But it just says do this. Okay, it's already selected Arduino Uno, and there are no other similar ones in there. So that would be it. Make sure I didn't mess it up. Yep, Arduino Uno. Oh, it even says that. See, it says board Arduino Uno. Okay. Make sure I hadn't messed it up. Okay. Now, probably it's going to tell me to go what port next time. Select the serial device of the board from the Tools Serial Port menu. Yep. This is likely to be COM3 or COM1. See, it's not like that in Linux. It's actually, as you can see, easier because it identifies it for you by the name of what it actually is. Whatever the device sends to the machine, it'll tell you that. I've noticed that over the years in Linux. It's usually quite a lot easier to figure out your COM ports because it gives them real names instead of just COM1, 2, 3 like in Windows. Let's see. These COM ports actually were they were serial ports, and then also for your modems. If you'd always have to, I used to always have to fight with getting. Sometimes they would change on you and stuff. Because if you have, if you have something plugged into the serial port, you're trying to find your modem to get to fax something. You used to always have trouble trying to figure that out. Let's see. Oh yeah, here it is. To find out, you can disconnect your board and reopen the menu and then try. It disappears. Then that's it. Okay, so I already saw it. Port, serial ports, dev, TTYC. It's not even say COM. Well, no, it doesn't say COM at all. ACMO, I thought, is that COM? But Arduino Uno, that's the only one because you don't want dev TTYS4. So that should be good there. Yeah. And programmer, it's probably the right one already picked. Run bootloader. Okay. Click out. Whoops. Click out here. We don't want to mess up our code. Okay. Now, yeah, port. No, because here it says COM6. See, this is kind of like Windows instructions, basically. But I understand. I've learned on Windows. I went over to Linux in 2005, but I still use Windows machines. So I just pretty darn rusty on all that kind of stuff in Windows. So on COM ports and all that. I have done it actually in the last 6 months. So I did something. I don't remember what it was. Probably fiddling with a modem. I think I was fiddling with a modem trying to fax something. Because I don't. Linux, you have to go way back in older versions of Linux to even get fax support. And so I just turn on a Linux, a Windows XP machine to do a fax, you know. So let's see. Now simply click the upload button in the environment. Wait a few seconds. You should see RX and TX LEDs on the board flashing. Oh, RX and TX, okay. If the upload is successful, the message done uploading will appear in the status bar. Okay. I'm gonna read this too. A few seconds. Oh, it's that little arrow button. Looks like almost like a play button. A few seconds after the upload finishes, you should see the pin 13 LED on the board start to blink, and if in orange. If it does, you've got an Arduino, or I can't say that, up and running. If you have problems, please see the troubleshooting. Okay, let's see. We'll go over here. Now I guess I'll just do this, and I don't know. I don't think we're gonna see anything. If we don't see anything in the window right away, I'll hurry up and switch to the camera. Okay, it's gonna be camera. I can see that. Okay. Switch. I guess I should have done it. Okay, I see a yellow light blinking. I started to pick it up, but let's see if I can kind of point it towards the camera. I wanted to see that. Yeah, oh, okay, RxTX. Yeah, they have LEDs on them too. I didn't notice that. They haven't started blinking yet. It's an L where that yellow light is blinking. It must be programming it still. Oh, my little red wire's kind of in the way, and I know it's way too small. I guess I should have zoomed in the camera. I was thinking I'd be able to hold it up, towards the camera, but that's not really, can't do that with the speaker hooked on here. Let's go see if we got an error. Oh, 3%. I'll go ahead and, well, you can't really see the Arduino very good, so let's go back over here for a second. Sketch uses 1024 bytes, 3% of program storage space. Maximum is 32,256 bytes. Okay. Global variables use 9 bytes, 0% of dynamic memory, leaving 2,039 bytes for local variable. Maximum is 248 bytes. Done uploading. Okay, it says done uploading, but I still don't see what I thought I would see. I just see the yellow light blinking and a green light. Maybe I didn't look quick enough because I was trying to do my video business here. But it says done uploading. Well, I thought it said something about you would get a message saying, okay, the RX and TX, I probably missed that. Oh, message done uploading will appear in the status bar. And then you should see L13. Oh, L13. Yeah, L13 is blinking. It says orange, it's yellow. That's sure a pale orange if that's orange. So I'm just going to lay it back down. But it worked. Okay, let me go back. But it doesn't see, I don't see anything, anywhere in here. It doesn't give the readout up here in your white area where you write your code. It gives it down here in this black mini command line area. But I don't see anything that says success. It just says done uploading. Maybe that's what it does. It probably just, differences in when that was written and what this program does now, I imagine. I don't know what I'm on. Okay, I'm on, yeah. Okay, learn more about the IDE, projects, and so on. Okay, so I think I know what to do now to load another project. And what's funny though is that I think I'll leave this one as it is. They're both, it's just another project window, so I'm just gonna delete that. And this was just like what opened up whenever I started, And I didn't see a way to download these things as files. I don't guess I'm going to end up needing that, but I'm not going to close it yet. Now, this is a simple song with the Arduino. Look at this algo carefully. More to come. Maybe a simple synthesis and music library will work by simply plugging a PC speaker between pin 10 and ground. You could generate slightly less square wave by using a capacitor and a resistor. It also works with the wiring interface. Now there's one here, and when you keep on going, much improved version. So I'm just gonna copy and paste this one. Whoops, you don't want that down there though. I'm just going to copy and paste it into the window of the Arduino IDE. Okay, if looks like I missed any. Oh, don't do that. When I try to page over it, it does something crazy, like it's an image. Okay, so I should have it. Let's go try it. I'm just right clicking, It's not. Oh, there it is. I'm gonna say it's not gonna let me paste. There it is. And I think I'll hit save as. Let me save it as whatever this guy calls it. That's what I have as a PC speaker, actually. Just so happened I had one in the garage that I'd taken out of a PC. So I'm going to hit save. I don't know where this is going to go. They asked me where I want to put it. Now it's got an Arduino. I'll just leave that on the that original name on the end in case I want to go back to. I'll take those spaces out of there. This program might not like that long of a name. I don't know. We'll try it, and if it doesn't like it, when I open it back up next time, I'll shorten it. Some of these programs like this, might not work with a long file name, and a lot of them won't work with spaces in there. If you see an underscore in there, you better use either underscores or I use dashes. They usually work just as well as underscores, but I guess that's how I copied everything in there. So, it's still running the other program. Let me see. Where does it tell you how to stop a program and then go do something else? I don't know if you. I think it. But it's still, that program runs forever. That light's still blinking. Let's see. Yeah, I'm still in my screencast mode. Whoops. I don't think I have any of those kind of instructions up, but I could have done one of those other examples, but I wanted to do that. Okay, I don't know if I should unplug it and plug it back in. I think I will. then it shouldn't be running a program. Okay, this is what I'll do. Where's my program that I just put in there? There it is. Okay. So I got that on. That makes it take too long. Put that back on cut. I had it on fade because I thought it might make the music fade. So what I'm going to do is unplug it because there's no power off button on it. I'm trying to do it without yanking on the wires I have plugged into it. Boy, that's hard to get out of there. Yeah, I knew it would jerk the heck out of it. Luckily, my wires that I have in there are in there good. They fit tight. Okay, so it's off. Now we'll plug it back in. Yeah, that yellow light blinks while it's booting up, and then after a while, I think it quits. It blinks the TY and TX too. TX and the RX, I'm sorry. TTY is in the Linux, so that communication protocol. Okay, it's just blinking again like that anyway. Well, I guess it worked. I don't really know how long it takes to boot up. I'll end up having to, in order to get my speaker up to the mic to try to play the sound it makes, if it makes, I'll have to, it's just sitting there blinking like it was before. Maybe it does that. Maybe it's, you know what? Since I've got that code on it, maybe it's going to run that code until I put something different on it. So let's just try uploading this one, because if I understand right, you can do that. Okay, build options change, rebuilding all, yeah. Sketch uses 3.584 bytes, 11% of program storage space, maximum is 32,256 bytes. Global variables use 398 bytes, 9% of dynamic memory, leaving. That's good to know that stuff, you know, because you can't put more than one program on these if you learn how to do it. Okay, but I don't hear the sound at all. Everything's still hooked up. So, but I don't see any errors. Let's see. I think it's still working on it. It says rebuilding all. It doesn't say done yet. Oh, it does say done uploading up in that window. Huh. I remember reading on some of these that it could take longer than you might expect, you know. See, I've done this before on my Texas Instruments board, and actually it was really hard to get to work. Well, I tried to do it in like Linux IDEs, and it didn't work. Well, it would turn out because there was a really small code limitation on the trial version of the IDE for the Texas Instruments MSP 430 boards, and so I tried a Linux one. And of course, I had never I'd never done that before, and it took a learning curve, but I finally got it to work. I ended up doing it with another Windows program that I downloaded, and once it worked, it was pretty cool. It was fun, and it was a little program that someone wrote just for Fram. Those, we call them Fram boards, but Fram memory. They have Fram memory, but MSP 430s. But there's a verify button. Okay, let me go back over here to the page where I got the code from. I'm not seeing that I have any errors, so it doesn't. I don't think it has any instructions on here. I guess they expect that you know how to do this. Okay, should play it. Okay. I don't know if you have to hit the reset button to get it to play it, or remember, seems like I remember I was reading through some of these codes today, so now they're all kind of jumbled up in my head, but in the comments and stuff. But it seems like I remember reading in one of them, you said hit the reset button. This one here plays 8-bit, 2 timers. Oh yeah, with this one you have to, it'd be harder, is what I was talking about. I think you have to load that code, and I think maybe you also have to load in this very small wave, sound data.h. It's a wave 2C modified to use unsigned samples. And I think you have to load these both in there. I think that's the actual wave file. So I thought, well, if I'm successful with the other stuff, I'll try that. So it's just sitting there saying it's done uploading. See, I'm going to hit that. Let me see. New, verify. Done. Compiling. It's compiling it, which it's kind of compiling. It's like building it, building the. This has got more space in there now, but it's all blank. Okay, here we go. 19%. Oh, that's how much it's using. Not. So I didn't fill it up or anything. Yeah, Arduino Uno on dev TTY. That's what the TTY is. Actually, I guess TTY is really the address. I always thought it was a communication protocol. But there's always a possibility that it can't drive this little speaker. But I'm pretty sure the speaker worked, when I pulled it out. I have another speaker over there. But, yeah, here's the reset button. Let me get over here on the camera now. That's my only... Oh, this whole time I didn't know I was still on the camera, so I was afraid I was going to end up doing that. But what I was talking about, I'll go back and show what I missed here. Sorry. I was looking through the code. I went up here and I clicked that check mark that says verify. And I was going and looking at some other code. I was talking about it, and I didn't realize that I wasn't showing it. But it says done compiling. I'll just leave it because I do know that it can possibly be slow. But what I showed a minute ago, this is the one I just put in there. Well, actually, the bottom one here. He's got 2 of them. And this one was the one I was talking about. It plays a 8-bit PCM audio. And you have to plug your deal into pin 11 instead of 10. And anyway, there's the code for that. And then down here is what I believe, what it looks like. It's a Wave 2C modified to use unsigned samples. So this is the file that it will play. You can't just put any file in there. So I think you load. I don't know if you put them both in. I guess you put them both in the window. I don't know if you put them both in the window at the same time, or if you put this one in and then this one. I've never done, I've never ran this thing before, so I don't know. And these are just like people sharing code, so they're not giving you, you're supposed to have already learned how to set up your machine. Of course, I don't want to do the little examples. I want to go try the real thing, So, so I'm shooting from the hip, as they say, and I have to go back and do a couple more examples or something. But the blink one, well, it's just still doing what the blink said it would do. It's just blinking that little yellow light. But it says in the IDE that it worked. This is that first one, blink the LED. Let's see. It's done uploading. They're not, maybe I shouldn't have 2 windows open. I'm going to close this window. Who knows? I don't think it would hurt anything because as long as it's not communicating to it both at the same time, it shouldn't hurt anything. But I'm going to hit the reset. Let me go back over here, and that's what I was fixing to do. Hit back on the cam. I didn't realize I was all on the camera the whole time. But underneath my plug there is the reset button. Let me look, make sure that's the right. I think there's only one button on it. Yeah, reset. So I'm going to reset it and see if it starts running that sound or something. Okay, now it restarted, I believe. I don't know how long you're supposed to hold it in. I just kind of did it, not quite. I didn't do it quite at like 4 seconds. I did it probably 2 or 3 seconds. And I just, you know, on the computer, I always set mine to do the 4 second. I don't like them instant off because you accidentally bump it. It turns it off. But it could be that my sound is just not playing. Could be this. I don't think the speaker's bad though. I didn't think about testing the speaker because I thought I knew it was good. And I have it on 10 and ground. There's only one set of 10s because you can't get that wrong. So yeah, holding the button in it won't do anything to you until you let go of it. So I guess you just mash it and let go. But it just blinks more, you know. It looks like it's rebooting because it stops the steady blinking, and then it's a little bit there, it starts blinking steady again. Okay, so let me try his first code. Well, let's just try this one again. Here, let me get back in there. I might not even been in the right place when I did it. Okay, we'll just do this again. So this is that code I put in there that's supposed to play some sound just straight off of the machine, you know. Okay. Well, now that's just giving those statistics again, and it says done uploading. Huh. So the numbers are all still the same. So I don't guess we're getting any sound out of that. Let's try this. I'll try his other code first before I move on to going back to, well, no, let's do another example. I'll try that blink example again. Let's see if it works. Okay, so I'm gonna examples, basics, blink, analog read serial, bare minimum, blink fade, read analog voltage. What are the other things? Digital. I think you'd have to have some stuff hooked up for a lot of this to do any of this. Yeah, sensors. USB keyboard. Huh. Starter kit. Spaceship interface. Love-o-meter. Oh, the starter kit. Yeah, you can buy a starter kit with a bunch of peripherals you can put on there. So, basics. Now I forgot which one they said to run for that. I think my computer's getting a little slow. Yeah, it is. Let me go see where my system resources are. I may have to stop. Yep, look at there. I clicked over there on my, OBS is using 2.5 gig of RAM. So I better stop this before I can't stop it. And I'll start back up after I reboot the machine and everything. So that's what I'll have to do. Okay, so this is done, and we'll come back here after a while take a break. Let the machine have a little break. Give me a little break. And forgot that I wasn't on the cam. Get the machine a break. Let me have a little break, and that's why it's taking so long to switch over. So, all right, it's done. Bye bye.